We're going to talk about microservices and Ruby because that's what our experiences recently in the past few years are in. This seems to be the thing that everybody's trying to figure out right now in the Ruby world, or really, if we say it, the Rails world. I've got a monolith. How do I create services from my monolith? And this usually comes down to this burning, painful issue. We've got a monolith. We're not making progress with the monolith anymore. It's too difficult to work with. How do I get out of it? I'd like to sort of underscore this and continue to underscore this, that monoliths aren't really bad until you make them bad. And the only way that they can become bad is that if those people who have access to the code are doing something to it. It's not like there's this band of evil elves that sneak into your Git repositories at night and take something amazing that you did in the daytime and turn them into crap. That doesn't happen. If things are going bad and you want out of your monolith, there's a group of people who are probably responsible for that, and it's probably people touching the code. And this goes to a lot of things that I think are plaguing the Ruby community and the Rails community, and not only our community, but many language and framework communities. And this issue speaks to it. Here's this just for example, when we thought fat model skinny controller was the right answer. And then that wasn't enough, so we got to service objects. And then Uncle Bob came up with interactors when he saw an opportunity to help out. So now we got skinny model, skinny controller, and interactor, and inevitably, that fat's going to go somewhere. So we just keep moving it around. Now microservices are going to be the answer. We keep creating this problem, and microservices are going to solve it. From one thing to another thing to another thing to another thing, we're going to have these magic solutions. And it's important to ask ourselves why we think that doing this, continually switching, is going to solve anything. So this is what you have. Some old sedan, it works. This is now what you want. And we're presuming that one leads to the other. One of these is going to lead to the other. But what makes us believe this, given that we believed in fat model skinny controller? And this is the unsightly and untimely problem that we're going to be facing as we try to take a monolith and turn it into microservices. A monolith is not a progressive stage along the way to microservices. In fact, they're opposite architectures. Unless you've built a monolith in a way that you can, in fact, do the things that need to be done to make a service-oriented architecture. And if you're not doing that, and you're just taking this monolith and going, it's microservices, that's the answer. We're just going to do microservices, and these problems are going to go away. Hey, look, we've got a lot of coupling. Fat model skinny controller is the answer. Service objects are going to fix everything. Microservices. The downside of this with this particular effort is that it's very high risk because you're changing, fat model skinny controller is moving the deck chairs on the Titanic, still within the same boat. Now you're talking about something that you could end up creating this dreaded horror show called the distributed monolith, which is really just a bunch of different applications, not a service architecture at all. And this effort is worth it. I think you're right. If you think microservices is the answer, you're right. Service architectures are the answer, are a good answer. And it takes a while to get there. It can take from 1 to 3 years on an average monolith transformation. But the clock starts when you stop making mistakes. You could spend 1 to 3 years and more not doing service architectures, yet not pulling the trigger, not doing what needs to be done before you even get to the point of actually starting the work, because you're maybe trying to avoid the work, trying to take shortcuts. There's no shortcuts here. Fat model, skinny controller, service objects, all that stuff, interactor, those were all attempts at shortcuts. How do I not move things around too much while gaining these incredible benefits? Well, they don't work. And in this case, it's going to not work even more. So you have to sort of look at, you've got to ask yourself this hard question. Where's your microservice project headed? Where's your thinking headed? There's two ways to do microservices right now. One is based on service architecture, which is what microservices is. And one is based on web development, which is what most of us presume microservices must be. Because how else could it be? Because I'm a web developer. And what else could the world be made of but web development? I am, therefore it is. These are the things we hear a lot from people saying, here's how we're going to get to microservices. They have absolutely nothing to do with service architecture. Some of them may help service architecture, but they have nothing to do with service architecture. In fact, these things are just mechanical sideshows. These are the small parts. So when you're starting your service architecture effort, and the first thing you're thinking is, I'm going to learn a new programming language. I'm going to containerize. I'm going to use a message broker. And I'm going to figure out my means of serialization and transport. Those are all kind of just like side details. That's not where your effort's going to be. Your effort's going to be in dealing with service distributed systems design, service design. In SOA, which was the thing that microservices came to save us from, SOA is the earlier generation of service architecture. The differentiating factor, and so we say there's smart pipes, dumb services. Smart pipes means you have a message broker that has logic. It has capabilities. You program the message broker and it does routing. You program the message broker and it does only once delivery. But in operations, when those things don't work out that way, you end up finding that you're debugging an opaque black box of message broker to try to solve application logic problems. What microservices says, not only, but one of the significant issues, is dumb pipes, smart services. Make the pipes dumb. That's where you're seeing lighter weight and lighter and lighter and lighter weight transports. gRPC is valuable. Protobuffers is a valuable way of doing message interchange and schemas. But what you got to put in the service code, in the applicative logic, is what's going to make the difference. And that's going to be the 99% of your effort and thinking. In SOA, we fell prey to this idea of magic pipes. The programmers don't need to do anything but write applicative logic. We won't worry with them about distributed systems problems. And if you've worked with Rails, you're probably already suffering from what happens when we try to deal with magic. In microservices, we're not trying to hide the distributed systems-ness anymore of it. And instead, by going to dumb pipe smart services, empower developers with the basics and the fundamentals of distributed systems, not the whole schmear. You're not going to go and, it's not like you have to learn what's involved in building Google. But there are some basics that you have to understand, and you have to do this kind of work when you're building services. When you're building applicative logic, you are going to have some mechanical handling messaging patterns and concerns to deal with. So here's how we do this right now and how we go wrong. Extract the product services. This is one of those keywords. You hear anybody talking about microservices and you'll get we're going to break it up or we're going to extract. That's where the red flag goes up. That's where your red flag should go up. That's an anti-pattern. Here's what this looks like. Let's say you've got a product model in your project, in your app. And hopefully this looks kind of like a normal thing. Like this isn't a big surprise. Maybe you don't have products in yours, but this is probably not a big surprise. This is a pretty common thing. You got a product, it's got a ID, a name, a description, a price, a quantity, and a URL to a picture in S3. You're totally gonna blow my talk right now, aren't you, Drew? No. Go for it.
Sorry, everyone. Can you go back one slide so I can take a picture? Because literally, this is exactly what we're doing right now. It's literally the service that we're extracting for our kind of proof of concept service. Hopefully, I didn't blow your talk.
I have Let's go all the way back here, Drew. And for the rest of the talk, I'm going to talk to Drew. In reality, this is a database table, right? It's a model, it's a database table. That's what's really going on. Sure, we got some Rails, we got some Ruby abstraction on top of it, but this is a data access controller for, not controller in terms of a Rails controller, but it's data access control for a table. And what we do when we extract the product services, we take that table, we move it into its own app. It's not a service. But we call it a service, and then we tell ourselves it's a service, and then we credit ourselves with having done the service extraction. And that hasn't happened. Because here's the #1 rule of services. Whether it's microservices, service-oriented architecture, distributed systems, it doesn't matter. You cannot query data from a service. If it's a service and you can say, get me the products from the service, that's not a service. Is your hair, I mean, if your hair was shorter, would it be standing up on end? Thank you. I'm looking for the effects. Aaron, if you could do a man bun as well, this would be very, very helpful for the visuals. Nathan, you're like nervously like, I hope it doesn't come to me. So the ultimate problem with all of this right now, with your current monolithic implementation, is the notion of centralization. You've got centralized data. You've got the row, the database, the table, the model. It goes from there, the service. But it's all about centralization. And what we're really looking for here is decentralized data. What the trend is towards as you go from monolithic to distributed is decentralization. And distribution, distributed services. Distributed data. You can't get away from this one. If you're going to go from monoliths to microservices, you can't just move the deck chairs around on the Titanic. This is like going from high school to university. This is the big leap. It's the right leap to make, but you can't get there unless you finish high school. So here's the principles that we've got to deal with. You shouldn't decentralize, or don't centralize data. Do move the data towards the things that operate on it. Don't query data from services, and do contextualize the data. And this contextualize issue is an important thing. And the answer to all this is PubSub, of sub form. I'm going to talk about PubSub, or publish subscribe, mostly in abstract, but some form of publish and subscribe. And how this works is we work with commands. So we got 2 services here, 2 nodes. I'm not going to call them services. 2 nodes, 2 components. Funds transfer is going to issue a deposit command to the account. And then if account can do that deposit, it will emit an event back, and then funds transfer will know that the deposit was going on. Because if you're going to do a funds transfer, typically you do a withdrawal to see if you can do it, you know, get the money, and then move that money somewhere else. In PubSub, the event is not just going back to the source, but out to anything that has the right to receive that event or wants to receive that event. And when we're really talking about, when we're talking about PubSub, it's not these commands, but about the events. We publish events and we subscribe to events. The command thing is important, but that's messaging semantics. But when we're talking about PubSub, we're talking about events. So the pattern is you handle a command. A command comes in, you handle a command. As a result of handling a command, a typical result of handling a command is publishing an event, or many. Irrespective of what the operation is that is happening, all these operations are typically happening by some means of PubSub. And this is basically how we deal with this. You send a funds transfer command to the account service. Sorry, funds transfer sends a withdrawal command to the account service. Account service receives the command, checks its account balance, and then makes a decision whether it can or cannot do the withdrawal, and then it emits an event based on whether it does it. Actually, in here, it's actually doing the withdrawal, but the event, as you'll see, is in fact, the publication of the event is in fact the doing of the action. And the whole purpose, the basis of this is this principle called tell, don't ask. If you've maybe heard this before, maybe not. This is one of the most important design principles or foundational principles that you can work with. And the gist is, you don't export data from a service and make decisions or calculations based on it. When you extract the product service, some other logic in your system still needs to know information about the product. So going and getting that information and taking it out so you can operate on it violates the most fundamental rule of distributed systems design. The product service would be authoritative over its data. You tell the product service what to do with its data. You don't export the data from the product service. By the way, that's the most fundamental definition of object-oriented programming. You don't remove data from an object. You tell the object what to do with its data. ORM is not OO. ORM is a little quirk that we allow in our systems to allow for data objects. But ORM is an abject, complete, and thorough and total violation of OO, and we know that, and we're okay with it. So we sequester it off to this tiny, tiny, tiny little part of our application. We say, that part is going to break the rules, because some data objects simply need to break the rules. Why? Because data is not object. Object is behavior, but you need data structures. What we do with Rails is make data objects the everything, and therefore you don't get OO, and therefore you don't get encapsulation, and therefore you don't get a path to microservices. The reason why you hate your Rails app after only working on it for 6 months is because of this. Even if you haven't connected the dots yet, that's why. That's the physics that's causing this outcome. And this is the fundamental rule you have to follow if you're going to get to services, real services, not distributed monoliths. And if you get to a distributed monolith, if you extract the product service, you make a distributed monolith, you get all the hellacious pain of your existing monolith with all of the nightmares of distributed systems programming. And the right answer, if you're going to do that, is to leave it alone and leave it as a monolith. It's perfectly fine to have a monolith. Perfectly fine to have a monolith. Just clean it up. Take the things that are painful and fix them in place. Don't create a distributed system. I'm going to hand it over to Nathan, and he's going to bring it on home. Right?
Hi. So a quick show of hands. Who here has been deeply exposed to event sourcing, has built systems using event sourcing? 2, 3. Okay. Who here kind of has a conceptual grasp of what event sourcing is, but hasn't really implemented? Okay. So this stuff might start out as being a little bit remedial, but I wanted to kind of ask that question because I first heard about event sourcing and sort of was explained the underlying gist of it in 2012, so that'd be 5 years ago. And it wasn't until 3 or 4 years later that I actually sat down and got working on some code that used event sourcing, because I couldn't find anybody that was implementing event sourcing, so it's not like I had any good examples to follow. So I'm going to kind of walk through the basics. For those of you that have been exposed, this will probably feel a little bit, you obviously will already understand it, but I'm going to go over it anyway. Event sourcing is based on this idea that instead of maintaining the current state of our entities in a relational database, what we're going to do as an alternative is we're going to store all the events related to a given entity in a stream, and then we can play those events back, and we can arrive at the entity that is derived from that stream. So I'm going to kind of explain how that works. So we have this notion of an event stream, and you can think of it almost as a binary log. Okay, events can be written to it, can be appended to it, but you can't insert them anywhere. It's not like an array. Okay, you can push only, and the events can never be deleted. They can never be altered. They're immutable. And if you've been hearing about all the wonderful goodness of immutable data structures and functional programming languages, this is actually the same concept, but it's at a deeper level of machinery. So every one of these events in this event stream has a position starting from 0. It has an event type. Opened is an event type. Deposited is an event type. And they all are associated with a given account, in this case 1, 2, 3. And we address that particular account through this stream name, account-123. And if you need something for your brain to hold on to, the notion of the combination of a database table in a relational schema and its primary key is a little bit, if you compose those two together and kind of squint a little bit, that's a little bit similar to what you're seeing here. You have a category like account. If we talked about, Scott brought up funds transfer, that might be another category. Dash ID, so it's just a string. I think of them as addresses. Now, streams can be read back after you've written events to them. They can be read back, and they're always read in order, starting from the beginning, although you can read them backwards as well. That's a nuance I won't get into. But readers start in the beginning, and they proceed forward sequentially. Okay, I'm going to go back to the notion of entity that I brought up. In Rails, we have models, and models really ought to be called entities in Rails, but they're called models in Rails. I don't know why. When we're using event sourcing, our entities are actually they only exist in memory. They don't have a mapping to any underlying relational database schema. So we construct the data structure. And it's just a plain old Ruby object with some attributes. And I'll show you how we can kind of project that entity using the events of an event stream. And it's just a process. It's a process that takes the raw materials, the events, and outputs a projected entity. Let me go here. Okay, so let's say we're starting with an account that's just a bare data structure. It's never had any data set on it. We just call .new on an entity. And we're going to read this stream from the beginning. And then every time we read an event, we're going to alter the account entity. So we read the opened event, and we set the ID of the account. Remember, this is an in-memory data structure. We're going to set the ID, the customer ID, and the open time. And then we're going to read the next event, which sets the balance it increases the balance by 11, because we deposited $11 into account 123. Here we've got a withdrawal that withdraws 10, so the balance is we subtract 10 from the balance and we get 1. and so on and so forth. And that's really all there is to event sourcing. If you have the ability to write events to a stream, and you have the ability to read those streams, then you can project the events of a stream onto an entity. And here's some sample Ruby code, and I'll show you some more here in a minute. But it's really pretty simple stuff. So before I go into the code, I kind of want to just show you this picture to give you an idea of what you're going to be looking at. In general, what these microservices that are built using event sourcing are generally doing is very simple. There's commands that are processed by a handler. So the handlers are processing commands, and they tend to write events. And those events impact future projections. And those future projections will cause the entities, like what we saw with the account, to have state that is derived from all of the past events that were written. And handlers can actually project the entities themselves, and I'll show you an example of doing that here in a minute. So, and then those handlers are able to use the entities to make a decision about what event to write or whether to ignore the message or not. So this is kind of a simplistic view of the flow. And just like in Rails, when you think about in Rails, we got form for, we've got what are the protected attributes, or the permit? I forget the name of that feature. Yeah, strong params. We got form for. We got active model serializer. Pretty much everything in the Rails world looks like a relational database schema. Similarly, in the kind of systems that we're building, everything looks like messages and message handling, and I think it's pretty liberating, but it is a little bit of a shift. So I think now I'm going to jump into some code. All right, time to do the dog and pony show here. Oops, there we go. That is excellent. I love that. I love that theme. All right. Oh man, I'm gonna have to type and. Thanks. Oops. So. Oh, I'm a Dvorak user. It's okay.
This is a borrowed laptop due to technical difficulties.
Great. I just love it. Everything about this is awesome right now. All right. So I wanted to show you this projection here. If you're familiar with languages that offer pattern matching, like Elixir, we've done something similar in Ruby, which allows us in our projection class. This class defines the procedures for applying events towards an entity, in this case, an account entity. So the actual handler code varies depending on the message type. A deposited event, we're going to increase the balance on the account. And for a withdrawn event, we're going to decrease the balance. So what we do is we handle or apply the messages based on their type, and we just apply some simple transformations on the entity based on the type. Actually, let me just back up. All right, so now we have a command handler, okay? And so now we're a little bit outside the realm of the mechanics of event sourcing. We're not talking about projecting entities or reading event streams now. We're just handling a deposit command and a withdraw command. And essentially what these handlers do is in the case of deposit, we write a deposited event that follows from the deposit command message to the account stream. And since the account's balance is derived from all the events, the deposited and withdrawn events in the stream, we know that by writing the deposited event, we are so changing the account balance, which is cool. And I really want to highlight here the withdrawal case. We've kind of got this handler here that is actually able to do a funds check. So if you attempt to withdraw $100 from an account that has only got $40 in it, this handler will actually cause the withdrawal to fail on the basis of insufficient funds. So, you know, Scott was talking about how services don't query data. Within a service boundary, you know, we're obviously going to need to read the transactional state in order to make that determination. So here, we write a withdrawal rejected event, and we broadcast it. You know, the act of writing event is also cause it to be published. So we write withdrawal rejected. If the balance is sufficient, we actually we just write a withdrawn event. Does that seem clear? Anybody have any questions on that? Cool. So I want to show kind of a couple other neat things. Here we have the account entity, and I'm going to kind of step away for a minute so I can go over it. So as I mentioned, you know, the account is sort of an in-memory data structure. It doesn't have a database table behind it. You build it in memory, and you use a projection to mutate it into the state for a particular account. What we have here on line 16 is this sufficient funds kind of predicate method that can tell you whether or not there's enough funds in the account for a particular transaction. And that is the notion, the object-oriented notion of encapsulation being applied to this account. And it's very common that we'll implement methods on the account that cause its state to be mutated. And we'll also implement methods that answer questions about its state. And so we can see in the handler code that actually makes use of this entity, you know, we don't even have to read its data to make decisions based on it. So every component of the whole system is encapsulated. All right. Let's see. And yeah, the last thing I wanted to show is the store, which is the closest thing to magic you'll ever see coming out of either Scott or I. The store is essentially a really, if you're familiar with DDD and the term repository, it's essentially a repository interface. It's an interface to return. It's a very, very lightweight interface for returning an entity. So this particular store, we've used a class macro to declare its entity. It's the account entity. We've declared its projection. We've bound this store to a particular concrete implementation of an account and a projection and a reader. And so what we're able to get is a very, very simple interface. Just store.fetch with an account ID will just give us back the account entity. So we actually don't see the offense sourcing happening in our code. It's more or less opaque because the tooling is there. But behind the scenes, this store is actually capable of quite a bit. Every time you request an entity, every time you fetch an entity from it, it stores the entity in the cache. The next time you get the entity from the store, it's going to start from the cached version. So if there were 10 events in the account stream when you first fetched the account entity, and then maybe later you fetch the account entity again, there's 15. The next time you fetch that account entity, it only needs to read events 11 through 15 because it's already got a starting point, which is a very important performance optimization because it would actually be quite ludicrous to build a system out of event sourcing if you had to, if you had an account with 1 million events, and I've seen accounts with millions of events, you would never be able to project it. And another thing that a store interface offers, oh, go ahead. You took the words right out of my mouth. That's no. No, the store also offers an interface for snapshots. Ah, yes. He asked, so if you have a cache that's in memory of all your entities, that's a great sounding performance optimization. But when you start your service cold and you don't have a warm cache and you've got an account with 1 million events in it, you're going to have to project all those events, which sounds like a non-starter. The store has an affordance for snapshots, which is I think of it as an L2 cache. So you can program in a snapshot interval and say every 100 events, go ahead and serialize the account entity and write it to a separate place on disk, so that if you ever have to read that particular account entity cold, in other words, the cache is cold, you're able to start from a version of the entity on disk. Well, number one, there's a single consistency boundary with an event stream. So when you write events to that event stream, atomically, you're atomically changing the entity. When you have like an audit trail, for instance, you have to end up wrapping everything in a transaction. You have to change the relational database table or tables if you have associations, and then you also, in the same transactional boundary, you have to update the audit log, which is it's undesirable to do so. The other thing is, I mean, if you ask me, having worked with these systems for a while, I would say that the amount of complexity inherent. I've worked in systems that had, for instance, millions and millions of job applications and job postings that were all versioned, okay? And that kind of system proved very difficult to work with because we'd often have to like, for instance, if we want to look at a job application for a job posting 6 weeks ago that was like that job posting was also changed for, fields were added to it later, reconstructing that particular posting from audit trails was next to impossible. With event sourcing, it's pretty trivial.
And ultimately, throwing it to relational database is perfectly fine if you only treat that.
It's perfectly fine as long as you treat the storage of the relational database as a cache. But once you put that entity in there, and then you hook up a whole bunch of other things reading that data for reasons other than warming up a cache, well, now you've got entanglement with extraneous concerns, which is what stops you from, it's basically what creates the monolith. What's that? No, I think we were just talking about, like, why couldn't you just, how is that different than storing the entity in a cache, in a relational database? If you could actually take the cached entity, which is just a Ruby object, and pump it through Active Record or SQL and store it into a relational database. We don't do that. We just take it in a serialized form and store it because it's only ever read and written by the store. So it only ever needs to have a format that's read and written by the store. But if you write it to a relational database and then you get tempted to use that thing for any other reason than warming the cache, there's no other polite way to say that other than you're going to get a monolith.
Well, yeah, no, I mean, that's a very, very good point. And the other thing too, this is getting a little bit more sophisticated. And then your question does come up a lot, and there's a lot of experience that goes into kind of comparing these two systems. But inevitably, with paper trail or any audit logging system on top of a relational schema, the implementation always, as I've seen, it's always like the same. It's not just one database table that you're compiling an audit log for. It's an aggregate root. It's a database table and several associations. When you're working with an event source system, each one of those different, what was tables in relational land is a different stream. And the PubSub mechanism that we're talking about, that pervasive notion of PubSub allows us to stitch together and reconstitute the state of the whole aggregate in a very, very simple and deterministic way. Inevitably, when you're doing kind of that audit log on the relational database schema, there is no nice way to say this other than it will inevitably become a giant pile of non-determinism and have consistency problems unless you just lock everything in a giant transaction, and then you'll have other problems like your ops people calling you at 2 in the morning telling you, your 2 a.m. background processing job has locked the whole database. If anybody wants to talk about horror stories with monoliths, I'm always down, by the way.
Do you have more content to go through, or should it just be our Q&A?
Yeah, I mean, I think we had an hour, and I think we're about up with that. I think Q&A would be really good.
We didn't show because again, 16 hours trying to cram into an hour, 45 minutes, 50 minutes. There's a ton of stuff that we're not showing here that we would show otherwise over the workshop, which is This is the transactional side. This is for the transactional side of the architecture. When you're, if any of you are thinking, well, how do I get data out of that? I mean, right? Like, why don't I just store a relational database? So in this architecture, you separate the doers of the system from the data of the system. And when you want to get data out of a database to put it on the screen, you don't do it out of these stores. These entities are only for, like you saw that entity, it's an account. Does it have sufficient funds for this withdrawal? It's just there to answer business questions, business logic questions. It's not there to retrieve data, put data on the screen, none of that. It's not for queries. And nothing else can query that data. But what we would do is have this other side, which you guys in Vancouver have probably heard the term CQRS bouncing around for a while, I expect. Maybe? No? Good. Okay. Thank you, Adam. Right. CQRS is great. It's just another one of those geek terms that we put on something to make it seem more esoteric than it really is.
I've got a level 12.
Raising Adam to the level
CQRS.
of local god or demigod with command query responsibility segregation, what. It just means the transactional side of your system, the doing side of your system, and the reading of data side of your system are supposed to be separate systems. And those events, you know, rolling back, because we have PubSub. Oh Christ, there's a new. This is actually good. Actually, circular, I like, that's good. Fuck, can you pull up the circular architecture slide?
Can we switch back to Scott?
No, it's over here and it's close up, but don't you have it on your machine? Oh, yeah, your Linux machine doesn't show data through HDMI.
It uses a circular architecture, so the HDMI cable doesn't work.
The issue is, because you have PubSub, well, if you don't have PubSub, you're gonna have a hard time getting microservices, real hard time. And because you have PubSub, pub and sub of events, because you have events, all of your data is already in events, you don't need the relational database to do this transactional processing stuff. Because you have events published about changes made to the state of an entity, we don't really have the entity stored. But you've got to sort of disabuse yourself of the notion that an entity or a model is something on disk in a relational database. It's just an object. You can constitute that object any way that you, with any technology that you have. A Rails model is no less more an entity than something that's just spun up in memory in Java. It's just an entity. Because you have events, because you have PubSub, you have events. Because you have events, you can take those events and create any database that you want. Because you have events and you can read events and handle events and receive events, you can shape databases for reading data and putting it on the screen in any way that you feel. You can even have a read side. You can generate Excel spreadsheets if you want it. It doesn't have to be a database. That's not a microservice. The only thing that is in a microservice, the microservices are on the right-hand side of the circular architecture that we're now, Adam, project it out of your brain onto the screen. You say you're awesome, show us.
I wouldn't recommend using the HDMI.
Oh God, there's so many bad jokes to make. How do I reconnect to the and what was I going to try to show?
I think you were going to say something about the first half of Saturday being free.
The first half of Saturday is free and
also very
sold
much
out.
sold out. I think Scott's going to pull up one of the slides.
Yeah, I like the word circular architecture for sure.
It reminds me of that when everyone shows React.js. They're like, React is really cool because
so now I
there's a
gotta
wheel.
run.
Yeah. 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 And it eliminates the assumption that when you're changing the state of the system, that you know what the new state of the system is. When you change the state of the system, you should be, not should, but when you change the state of the system, you're unaware of the state. When you query the state, it might be out of date. Yeah.
Oh, crap. There he is. Well, okay. Thank you.
Oh, yeah, you don't have to. Yeah. He's saying, is this just like your opinion about microservices? Yeah,
Yes.
I absolutely. So the part that's not an opinion, well, I'll say that using event sourcing is a choice. You could build microservices without event sourcing. The reason I like to pair the two together is that when you have the notion of services that maintain transactional state but they don't query each other, then you really end up with a really hard time painting web pages. So you have to stand up what is often called read models or view databases to power actual UIs. Event logs, event streams, evented systems essentially give you the ability to do that at a very low cost, very easy to do that. When you have a bunch of services that are all running on top of relational databases, you have to replicate their data with some kind of ETL process to get that into a read model that you can use.
Which, by the way, is an event source system.
Yeah.
Buried in technology that you can't debug. At the Bayside Bar, of all places. Well, it's Facebook's JavaScript developers, to be honest. I mean, let's.
Question over there.
Just kidding. It's just kidding. Can we? I'm sorry. Just before you go on, before we continue, I do want to return to the fact that Adam knows this. I know this. The people who do this, people who've got experience with distributed systems know this. When we're talking about the data side and the events, making any database you want, the services side of stuff, the microservices side of stuff, that's the transactions. That's the doing of things. That's not an opinion. That's what service means when we talk service-oriented architecture. And from service-oriented architecture comes microservice. So when you say service, and you're talking about microservices, you can't make up another definition. It means something, and it leads you down a certain path of development and process and architecture. Services are over here on the left. Databases that you read from to put stuff on the screen, those are not services. Those are databases. And you may have things that put data in the databases and shape that data in a way so that when it's queried, you don't have to do a lot of joining and transforming and converting and all that kind of crap and ETL. There's no ETL here. It's just the data's ready to go. If you ever heard of anybody's ever worked with a database like Cassandra, or if you've worked with Mongo in the way that Mongo was supposed to be used, your data is supposed to be ready for querying, right? It's supposed to be ready for presentation at rest. So the least you have to mess with it to change it, convert it, join it, and paint it to get it on the screen, the better it is. Although that's a little bit of an idealistic perspective. You can start with relational databases and do the joining and stuff like that. But the point is, this side of the world is data. It's just data. It's not services. It's related. You can't get away from it. Same way that you can't have, if you have services but no applications, you're probably not going to have users generating value out of those services. So you need it. But this is where services are. This is where data is. The two interact. They're very related. They're cousins, let's say. But the flow of information is circular. I don't know if that's what Adam meant by circular architecture, but the flow is circular. Commands come in from the transactionals, from the apps, go into the services. The services emit events. The data side picks up those events, decides how to shape database tables that it wants to keep a hold of, either for analytics or for display. And then the applications will get that data or use that data. Also, the application is not thorough. The applications can also receive events as well.
Yeah.
So what was, I'm sorry, yes, there's one, but I interrupted a gentleman. Sure, I love giving that answer again, so why don't you set me up? We do. No, it's really the salient question. So the question was, which, we've got a lot of data. I've got an existing application. It's got a lot of data. Which of it is appropriate to put in one of these stacks? And it's if the data. So applications aren't monolithic, by the way. Data is monolithic. You can have monolithic data, and if you build an application on monolithic data, it's a monolithic application. Applications are not inherently monolithic. Data is monolithic. If you've got monolithic data, it's going to take you a while to get out of monolithic data. And the reason why you want out of monolithic data is because it gives you monolithic applications. And the reason why that's a problem is you got 40 developers all committing to the same code base, and half of your developers are spending half of your time doing production support.
It's actually a lot worse than that. Because
things go wrong. And it's like, what's the value of microservices? Things are isolated. They don't break and take down the entire neighborhood. They just break, and one house burns down, but it doesn't take everything else with it. You can take a service offline. You can take a service offline, and nothing else goes down. Why? PubSub. If you don't have PubSub, you can't do continuous deployment. Oh, no, you can do continuous deployment with load balancers. I forgot about that. And that's how you end up spending half of your time spending your development time doing production support. So I know this is going to sound nuts. Why do microservices? Because when Nathan and I work on systems, we spend no time as developers doing production support. No time. We finish the service, test it, run it. They very rarely have problems. They very rarely need operations. They very, very, very rarely need developers to be pulled off their jobs, pulled off the line to do something that is not development work. And that's not something that we can substantiate except to say, you should try it. So how do you get your data that's monolithic into a non-monolithic stack? Well, it's a 1 to 3 year process. And if you undertake it, you'll have really fantastic productivity outcomes.
And I kind of want to touch on something else that you said too, which, and I could be reading too much into this, but I know that in my experience, this was the case. When you're new to this different approach, there's a psychological game that starts to happen in our minds where it's like, this is very different. This is very uncomfortable. And it seems like I want to apply it in those situations where it's going to be of obvious benefit. But I want to keep doing things the way I did before when it doesn't seem appropriate. The reality is you could write Vim with this kind of architecture. You could write any kind, this approach, CQRS can model any kind of software you can dream of. It has to do with the web. When proficiency is gained, when one has proficiency building systems like this, the cost of modeling a system this way drops dramatically. But you have to have the fingertips proficiency, the muscle memory doing it, to be able to make the analysis and say, okay, I can understand the trade-offs using a relational schema or a graph database versus event sourcing here. But from my experience, after gaining the proficiency, a lot more things become clearly not only able to be modeled with event sourcing, but ideally modeled by event sourcing.
The proficiency thing is huge. It doesn't address your question though about how do you get data from a monolith to, that's not an easy question. Like I said earlier, a monolith is not a logical step on the way to a service architecture. They're actually on opposite ends of the architectural spectrum, and they're opposed to each other. But the proficiency thing is really important, and it's really fascinating to think of the things that you use on an everyday basis. So, not to bang the old, remember when we were young, Adam, and things were. Adam was never young, so that's not an issue. Who's been young? Who's been young? Who's presently young? You're not young. No, I'm just kidding. Let me tell you what young is. It was I haven't slept in 48 hours. Who has been around for like more than 10 years? All right. So before there was MVC in the web MVC, there was these things called server pages. And we had to fight to get to web MVC. And we didn't have proficiency. You think you didn't have proficiency in web MVC? I went to a code school and learned MVC in a week. Yeah. Once it was known by everybody else. But in the transition between server pages and web MVC, that was not a difficult time. We had to gain proficiency. We had to sell it. We had to fight for it. We had to fight managers who wouldn't let it be done. In the transition from hand-coded data access layers to ORM, by the way, which was also happening at the same time, we had to fight for it because we didn't have proficiency and everyone was afraid of it. This happens again and again and again and again. And if you've been here for 5 years or 5 months, you think, well, it's probably always been web MVC. Absolutely not. That was 2003 at best when that came in. And before that, it was anybody's guess. It was active server pages. It was Java server pages. Before that, it was cold fusion. PHP is another thing. No, that's not a put down. That's not a put down. It's actually a different kind of technology. But like, it matters. Like once you get a handle on this, you know, we say this a lot. It's like we would given a chance to work on a new code base. Would we opt for web or MVC, as we tend to call it, an ORM, object relational plus MVC? Will we do that, or will we start with event sourcing and microservices? Well, we already know this stuff. It's like asking, hey, if you're going to start a new app, would you do it on Java server pages or active server pages, or would you use Rails? If you asked us that 5 years ago, it would have been Rails because we'd already got the proficiency.
What would you say if I asked you that today?
I would say yes. So that matters. And this is unfamiliar. But guess what? Everybody who's been through multiple transitions of technological waves, generations will know this. It's your job. You're going to get disrupted. Your career's going to get really disrupted a lot of times over the years, and you're going to have to make switches. And MVC and ORM are not de facto standards. They're just new things from the perspective of history. This will get disrupted with something else that improves on it, but we're always improving until we arrive at a tipping point and we get a disruption. This is one of those things that I think it is a disruption. Not really like disruption is going to change the speed at which you develop your world and create value for customers. It's like, no, it's just going to make things easier. We're just going to make an incremental benefit. We're going to take an incremental leap by making a massive disruptive change to your workflow. Welcome to the business. At least it's not like, hey, I'm really good at Rails, I'm really good at Ruby, I'm really good at Ruby. I want to do microservices because I've heard of these benefits, productivity benefits. All right, here's what we need to do. Let's learn a new programming language. This is good. Because no, there's my, Aaron, pretend you're my boss. Aaron, boss, I'm going to do this Christopher Walken for some reason, because I haven't slept in 40 hours. So we're going to do a system, and I need money, and you're going to give it to me. No. So we're going to build a new app, and I'm going to do it in a new programming language and a new architecture. Check it out, right? New language and new architecture. So it's going to be a new language, right? And you know as a boss, because you've been around, that when I start using a new programming language, everything I build for the first year is absolute crap. And I'm going to start with a new architecture that I barely understand. So I'm going to take the worst possible ability, skill level, put it with the hardest possible architecture. Huh? Yeah. So, which is, you know, this is an interesting, I've been like debating with Drew about the value of like switching your programming language. Don't switch your programming language to adopt a new architecture, especially when you're adopting a new architecture at a time that your skill with the programming language means you're going to be absolutely crap at that programming language.
Well, this is just probably not the best time to let you know this, Scott, but I've decided to switch to Elixir.
Always that. It's like,
yeah.
Marsha. Elixir.
All right. So would you consider tools like AWS Lambda, assumption written as that, in AWS Lambda as a microservice because it's a simple function that performs an action on something.
That's probably not a microservice. That's a
Is it authoritative over its data?
it's reacting to events. It's reacting to messages. It's distributed reactive programming, but it doesn't. It may be a microservice, but by definition, it's a smaller unit of composition that you might compose a service out of. In and of itself, it may be a microservice, but may not be.
I mean, at the end of the day, that is a deployment topology. So it's a little bit, it's a little bit, or it's kind of more or less orthogonal to service architecture, the way that we reason about it. Because a Python script running in AWS Lambda is not a whole lot different than a Python script running on an EC2 instance or on a physical computer. Okay, lots.
Wow.
Lots.
All the way in the back.
What I said must have been wrong. For that many hands to be raised now.
How
Talk
do you
to the
deal
box.
with transactions? So like, for instance, in the withdrawal deposit example of operating on two different accounts, and let's say like either one could fail. So a deposit, maybe an account's locked or something.
Can you come up with another? So an account wouldn't be locked. Yeah,
The feds have locked it.
Mm-hmm. Mm-hmm. PS.
Yeah. Yeah.
Right. However, yeah. So interesting enough, that's actually the problem set that we're going to work over the weekend. 16 hours of dealing with actually getting things to work in a distributed system. But it's a fundamental sort of presumption, hopefully, in distributed systems that you don't lock. So you won't end up with an account that's locked. There's a totally different universe, a totally different physics that we're dealing with.
When I say locked, I don't mean like database locked. I mean the account is locked by the bank for some other reason and not open, or.
Oh, okay, yeah, that's fine. Oh,
Yeah, that might be the
that's
basis
fine.
for a different set of considerations.
That's merely the issue of a funds transfer communicating with an account, saying do something on my behalf, and the account service component responding back can't be done.
Or publishing, it can't be done.
Yeah. And at that point, that's up to the funds transfer component or whatever the other component is to understand how to take action in its own logic based on that state of affairs. And those are very realistic things that you have to deal with when you don't have an atomic monolithic system.
One more.
It's actually really, it's funny, I'm sorry. It's refreshingly simple when you finally kind of see it, but the machinery of getting it done actually has to intermingle with your thinking about applicative code, which can make it a little bit challenging at first. But when you finally get your head around it, which can take a little bit of churning and working and practice.
Take a whole weekend, as a matter of fact.
Yeah. When you finally get your head around it, it's really refreshing, and it's amazing how well these things behave and perform in production and don't require hand-holding and babysitting and developer time.
I think we should take a couple more questions, definitely.
Yep, it's you.
Walk into the box. Okay. Forgot my question. I'm so distracted by this box.
That's cool.
Oh yeah. You keep mentioning event sourcing and PubSub kind of in the same breath. I was wondering if you consider those things to be intrinsically linked, or if you would ever have a situation where you would want event sourcing but not PubSub.
Well, event sourcing is almost a degenerate form of PubSub. If you have events, if events exist, it's because events have been captured. That can mean that they've been published, as in a PubSub means, but events have come into existence. If we just leave it at that, events have come into existence, then you can have event sourcing. So if you have PubSub, events have come into existence. They've been written down on disk, you can do event sourcing. If you can have PubSub, you can have event sourcing. If you can have event sourcing, you can get the relational finagling, the wrangling of the relational database out of your controllers.
Yeah, I think when you have events, when you're writing events, you're doing PubSub. It's your choice whether or not to subscribe to it, but that's just inherent to what you're doing. Yeah, that's true. There's a lot of systems built that way.
So, I'm sorry, it's for interrupting. If you think about what we're doing in a Rails app, you get a post coming into a controller. You're retrieving models. You're figuring out what you got to change in those. This is just within the space of a web request, and maybe in a controller. Maybe you've got a thin controller and it's a fat interactor. It's all happening within a web request. You're figuring out. You're making the changes to models. You're validating the new model state, and then you're saving them. The saves trigger callbacks and maybe some background jobs, right? When you're doing this with event sourcing, the controller receives a form post. You project an entity, decide whether or not whether that form post is valid, can be done or not. And based on whether it can be done or not, you've got a yay or nay, like a yes, no, it's good or it's not good. That's it. You write the resulting event. There's no wrangling of relational database models. You write the event. This is the result. If you told me to do a deposit, and if you told me to do withdrawal, and I decided that I can do the withdrawal, here's what I would have done. That's an event. I did a withdrawal. But it doesn't modify a relational database table. The value here in doing this as an architecture for applications is that you take a whole chunk of the things that you got to figure out and worry about and operate and worry about, as we talked about earlier, locking, deadlocking, all the things that go along with relational databases and atomic commits. And you can remove it completely. And you move it because you want this stuff in the database. You remove it to another system called the data side, called the read side, or the read model.
Worry about I have to modify column and table, things like this. A nightmare. Versions of rows, adding history tables, all of that garbage goes away. Data migration goes away. You're protecting up. So I could go on to the play file. Because it addresses all these advantages, I can't find something else that works better.
Yeah, but they are intrinsically they're not. I don't know if they're intrinsically related. But they work really well together. Like if you got one, you can do the other. Oh, and if you're going to have microservices, autonomous services, you're going to have PubSub. If you're going to go there, you can go here.
Yeah, we can
Are
get
you
into
coming to the workshop?
So we only have time for 2 more, and there's somebody with the box, and the box has priority right now.
Well, thank you, but my question's on a bit of a different tack. Did either of you read Mark's blog about event sourcing, DD?
From a number of years
2
ago?
months ago. Well, I think it's only 3. Maybe I only saw it 2 months ago, but yeah. Just wondering what your thoughts are on what he said there. Maybe you can tell
Well,
people
so
what
Martin,
he said.
the most wonderful thing that what a wonderful thing it is to have Martin Fowler in the universe, because he's able to gather the things that are going on in the software world and condense them down into well-written pieces and communicate them to the rest of us. But most of that stuff is kind of already out there in the world. There is one incident of an article, I think back in the day, where it got a little bit wonky in the early interpretations of CQRS. So I know there was one article that was a little bit controversial because there was some purported misinterpretation. So I'm not sure which piece.
Yeah, well,
that
maybe,
you're talking
yeah,
about.
that's, okay, sorry, so I didn't realize there were a number, but I mean, basically, yeah, okay. I mean, okay. Yeah, I don't think it was that one.
Command sourcing and property sourcing and yeah.
And then there was the recent one which shows different approaches to
I-
event sourcing, and that's what you refer
I think so. I mean, basically what the TLDR is like, he was basically saying everyone's doing it wrong. Like, guess what? Once again in our business, we come up with the magic bullet or something that's better than what we're doing, and everyone runs off and starts doing it wrong. So you guys are doing a great job of like trying to correct that, and Adam and his guys
Cool.
are trying to do a great job.
Thanks.
Because you're telling us how to do it. It was great presentation, but is there something about this approach maybe that you think is going to be easier for the industry to adopt than say some of the other silver bullets that have been marketed over the last 40 years?
I like it. I mean, I've made the transition personally from, ORMVC to event sourcing. It took me a lot of years to figure out like what the heck it was and how to do it, and then a lot of experimentation with how to build libraries to support it. But now that kind of deep into the transition, really want to do it the other way. But that doesn't say much more than I'm now used to something and I'm now attached to something. I might have a fixation on this, and that might not be like a thumbs up for event sourcing. It might just be that I'm like got some sort of addiction to it.
So is there something you think?
If that's not the case, though, if
So you
that's
got a
not
fever
the
and the
case,
only cure is more event sourcing.
more event sourcing. I got a fever. If
So what
that's
should
not the
somebody do
case,
to make it?
I think that from the people that we've introduced it to and have adopted it and tried it, that good stories are coming back, and it's not merely about enjoying yourself doing it, but it does take a big pile of complexity out of the life cycle of getting something done in an application, and it does shift it somewhere else, but then it puts it in isolation and makes it easier to change, easier to deal with. And I think those things are incredibly valuable, and they really help our productivity and help our sanity. Like it's enjoyable to work on these systems, where I don't find it enjoyable to drop into a two-year-old Rails app. Like I know what I'm going to be facing. It's like I drop into a 2-year-old, I know what it's going to be, and it's not going to be nice. But if I dropped into a 2-year-old service, well, if the service was done 2 years ago and it hasn't really been modified that much, like it's not constantly under change and under churn. There's so many unrelated things going on, like triggering callbacks because you saved something, and then something queuing of some background job happens, and that, like Nathan said, locks the database, and now we're going to go and work on solving that. But like that stuff just doesn't happen anymore. It goes away. The Ruby Goldberg machine. Yeah.
Yeah, we can't take credit. Okay.
So it's important to say like complexity is something that is you can run static analysis and come up with a mathematical measurement of complexity. Rails is really, really complex. It might seem simple because a lot of it is hidden in magic, but well, yes, it is fast to build a prototype. It's really fast to do something when you take all kinds of shortcuts. And we use Rails because it gives us all kinds of shortcuts. And that's a business value. You want to take shortcuts. But know when you're taking shortcuts. Like, it's not like, the problem was originally we're going to do Rails because it allows us all these shortcuts. And then we know, because we've been doing this for a while, we're gonna have to fill in the blanks later. What happened was it became a cult later, and the whole doctrine, the whole book of shortcut was removed from all the classrooms, and no one was allowed to talk about it anymore. And now it's like, this is not a shortcut. This is the architecture. And it's like, no, this is a bunch of shortcuts. You should
Majestic, man.
don't adopt this like a religion. It's not enough. It's insufficient. It's a good way to get started. It's not a good way to keep going. Yeah, and so Aaron was just saying that unfamiliar is not the same thing as complex. Unfortunately, we tend to conflate those things in our minds because both of those cause anxiety. And when anxiety gets raised in the mind of a programmer, we often reach for this word complexity. That's complex. It's like, no, complexity is something I can figure out with static analysis. It's a number. Cyclomatic complexity is a simple algorithm to run over any code base. The code base said that's complex. Any static analysis tools can show you what complectedness and entanglement is. That doesn't mean that it's going to be, that you're ready to do it on day one. Drew, are we going over time or we're good?
I just wanted to quickly say I looked up the article. It was called "What You Mean by Event-Driven," and Martin Fowler kind of discussed a few things: event notification, event serialization, for event sourcing, and the too long.
TLDR, too long to read?
Don't want to read, whatever. Was basically he either doesn't know enough about it or doesn't have enough time to expand on it to write enough for this to make much more sense than what you just heard me say.
That's amazing. The first thing I do when I get back is I'm gonna read that article.
So there's a lot,
read it twice.
The gentleman mentioned concurrency. There's a lot of interesting ways to deal with concurrency in an event or event source system. And on the second day of the workshop, and this is not a sales plug because it's sold out, so we're now absolved of being mere marketers. On the second day of the workshop, we're going to spend a lot of time talking about how to deal with concurrency in these systems and item potency and messaging patterns and actually dealing with the real problems of building these things. And they don't just apply to Ruby. That if you're going to go off and do something in another language, it's still the same stuff. It's distributed systems development. So how do you deal with concurrency in an event-oriented system or event source systems? You do it with some sort of representation of sequential time, and sequential time is always represented in the code and in the model. You don't get away from it. It's always there. And for our case, we do that with a version number, and we'll explain that in great and painful detail. You saw some of it when Nathan was showing the projection animation, that there was a position and a version number. Well, position, version number, about the same. They mean the same thing. But you track the position. Every event has a position, and you can know when one event happened and one other event didn't happen because they're at different positions. And you can derive time. You can figure out one thing happened before the other thing. Well, is it first one in wins or is it last one in? It's like, that's business logic. You figure that one out. But at least you have a way of knowing what came first and what came second. If you don't have that, go ahead. What? Oh, that's funny. Yeah. Oh, the chicken or the egg. And,
Let's take one more question. Then we'll be available to answer questions afterwards. We'll probably go out for beers or something. We'll can meet up, but we need to take one more.
It works. So say I'm sold and I like all the things I'm seeing. You mentioned that the service-oriented architecture like this isn't a natural progression from monoliths. So as somebody who likes working on one, like somebody already operating in that space, will you, because I'm already sold, I literally just like bought the tickets, not just, but are there tools or techniques where you can make an incremental shift into this
I'll speak to that. There's good news and there's not bad news, but there's challenges. Yes, there are incremental steps. Understanding what steps to make strategically and tactically for a given monolith takes a lot of it. It deserves a lot of analysis, and it's possible to get those kind of decisions wrong, and it's very costly. And in my view, when you've got a monolith and you want to transition to services, the first thing you got to do is learn how to build services. But that's a small portion of the total amount of work ahead of you. What Scott said, he gave us the answer actually in the beginning, which is to make your monolith ready for services, you have to build the monolith you wish you had first. When you build services and you understand what they are and you understand what encapsulation is and autonomy is, you'll understand how to even determine if your monolith has got the characteristics you need to be able to detach individual components and make them into services.
So essentially, I have to know what a hammer is before I know
Yeah,
what
it's
I can nail down.
what is it, Mr. Miyagi, the wax
Well, no
on,
one,
wax
no,
off.
yeah, well, no one really ever put that limitation on programmers anyway. So you can just grab a hammer and start banging on everything if you want to.
That's how we got into this mess in the first
No, I
place.
know, that's just it. And by the way, this hammer, this is Thor's hammer. You can smash your universe. This is what I'm saying. Like, you might want to figure out your strategy to getting the services. And it's not just let's abandon the monolith, because monoliths and services are not compatible. And one doesn't lead to the other. And you'll hear these stories of, well, let's just build our services and we'll make them run on the same old relational database we already have. That's a big maybe, because the monolith is the database. Like, forget about your code. The data is monolithic. If you say we're going to build services and we're going to put it on monolithic data, it's like that's like I don't need that those two, like, that's 2 + 2 = 75. It doesn't make sense. Two sides of the equation don't add up. But there's no like single formula. Like, every monolith has its own set of inherent interesting mutations, and you have to resolve those. But it's true. Once you start to understand how services are built, how to work with them, you'll start to understand isolation and encapsulation and boundaries. You may adopt, esoteric pattern languages if you feel like domain-driven design to help you along the way. And you'll never write a monolith the same way again. And it's really good. Like, you can still leverage monoliths. You can still use it. But I would never write a monolith the Rails way. I would use Rails, and I would isolate Rails in a corner, and I would build my, yeah, yeah. Yeah, but it'll fundamentally change the way you do this stuff. And you will end up writing monoliths that are a little bit easier to get from one to the other. But even if I sat down and wrote a monolith, it wouldn't be just ready to become a service-oriented architecture, because they're not the same thing.
Thanks.
All right, thanks everyone. Thanks very much to our speakers, Scott and Nathan. That was great.